All right, welcome. This is using coordinate geometry to prove shapes. This is Mr. Giovanelli with Agua-Free Distance Learning. All right, what you're going to see today is a lot of the things we've been working on really kind of come together into one lesson. So our goal here is we want to figure out how we can prove or disprove geometric figures using coordinate geometry. So another way to think about this, we're really like getting into this part of the standard here, proving or disproving geometric figures. And what we're really doing is using the distance and the slope formula to do that. So something you're already familiar with, but now we're going to kind of put it all together. Okay, getting into today's lesson, one of the big prerequisite skills is remembering how to classify quadrilaterals. So let's review really quick that a quadrilateral is any four-sided shape, but there are a ton of different types. So it's worth our time to let's review the family tree here. So if you call something a quadrilateral, really all you've said is that it has four sides. All of these that you see on the page here are quadrilaterals, but what we're interested in is providing the mathematical evidence to know exactly what specific type of quadrilateral we're dealing with, or any shape really, but you'll see a lot of quadrilaterals. So for example, like we've worked with parallelograms. Well, a parallelogram has opposite sides are congruent, they're also parallel, so opposite sides are parallel and congruent, right? And they don't have any 90-degree angles, right? But all of these below, these are also all parallelograms because they have everything that this parallelogram has. They just get more specific. So like, for example, a rectangle has those opposite sides are congruent and parallel. It also has 90-degree angles. A rhombus has opposite sides congruent and parallel. It has all four sides congruent. A square is kind of a mix of the two. It's got all four sides congruent and the 90-degree angles. So it's really important for you to be successful is to know all the qualities of these distinct shapes. We have our trapezoid here is just defined by having one set of parallel sides. Our kite has no sets of parallel sides. It's got some congruent sides, but no sets of parallel sides. I recommend here that you maybe take some time writing the things down from this chart. These are like, the qualities in words. What you'll notice is that anytime they're saying opposite sides are equal or parallel, or like things like angles are 90 degrees, we have ways to prove that using the distance formula and then the slope formula. So this is what we've been kind of building to for the last couple lessons. We want to now apply the distance and slope formula to take a shape and say, okay, I can prove that the opposite sides are parallel, all sides are equal, all angles are right angles. This shape must be a square. All right, I would add this here to your notes. So to provide mathematical proof of the qualities of a specific quadrilateral, so when you're trying to figure out which specific quadrilateral it is, or any shape really, it doesn't have to be a quadrilateral, but any shape, you can use the distance formula to prove if lines are congruent. You're looking for the same value. You can use the slope formula to prove if lines are parallel. So if they have the same slope, they're parallel. You can also use the slope formula to prove if lines are perpendicular. Remember, we're looking for either negative reciprocals or zero and undefined slopes. Either of those situations will give you perpendicular lines. So it's really important, obviously, that you know the distance formula really well, which we worked with in previous lessons, and the slope formula. All the info is going to come from those two formulas. All right, let's look at a situation here where imagine like all the math had already been done. We're just analyzing the final results. I want to start with that and we'll get to doing the math a little bit later. But your friend Gio here is claiming that the quadrilateral math is a rectangle and he shows the following evidence of math's distances and slopes. Is Gio correct? Explain. Okay, let's figure this out. So one of the first things we want to think about is what are we expecting from a rectangle? So a rectangle should have opposite sides are congruent, right? So our math should show that. We should also say that opposite sides are parallel. So our math will have to show that. And then finally, I'll write the third one up here. We should see that all angles are 90 degrees. If those three things are happening, we have a rectangle. So let's take a look now. Let's analyze the math. So here we have MA and TH are 8, AT and MH are 52. So that's proof that opposite sides are congruent. They're not all the same length, but the opposite sides are congruent. Okay, now here, looking at the slopes, I'm noticing that the slope of MA is equal to the slope of TH, and that the slope of AT is equal to the slope of MH. That's proof that opposite sides are parallel because the slopes are the same. Then finally, where do we look for evidence that all angles are 90? Well, if you compare the slopes of the sides that meet, if you have negative reciprocals here, which we do, negative 2 over 7 versus 7 over 2, that's proof that the angles are 90 degrees. One quick thing about negative reciprocals that I didn't show you last week. Another way you could tell that they're perpendicular is that if you multiply them by each other, you'll always get negative 1. So that's another way sometimes people explain that they're negative reciprocals. But what we've learned is that the fraction flipped, the sign flipped. So that's proof that we have 90-degree angles. So we know for sure, based on this mathematical evidence, that this is a rectangle. We didn't even have to visualize it. We could see it from the mathematical evidence. All right, now let's look at a situation where we are going to do all the math ourselves. So we're going to test whether Jolene is right here. Jolene is saying that this ABCD shape, when connected, form the vertices of a parallelogram. Vertices just means these are the 4 points of a parallelogram. So we got to figure out if she's right, and we got to prove our answer using coordinate geometry. Okay, so a good place to start is let's explore all the lengths of every line. So let's figure out the length of AB, the length of BC, the length of CD, and the length of DA. Okay, we're assuming that the points all connect in order like that, right? So like we've kind of been doing, so it doesn't get tedious, I will do the first one as a model, and then you can pause it and you try the next 3 before I reveal the answer. So here we go, AB. We're going to find the length of AB, so I'm going to use the distance formula, right? So I'm going to say x2 minus x1, so that's going to be 1 minus 6. Okay, I'm looking right here. 1 minus 6 squared plus 2 minus 3 squared, looking right here now. y2 minus y1. All right, and now I just have to simplify this to get my answer. So I'm going to have the square root of negative 5 squared plus negative 1 squared. It's really important just to like check your negatives and be really cautious as you're doing this. It's easy to make small mistakes. We're squaring numbers, so we're always going to get positive numbers at this point. So we have 25 plus 1, and then we're going to get the square root of 26. Okay, let me check really quick. I can make that the square root of 13 and the square root of 2, but neither of those can be reduced, so I'm just going to keep my answer as the square root of 26. All right, you go ahead, pause it here, do the next 3 distances that you see on the screen. All right, as you can see here, the math popping up on the screen, we've shown that opposite sides are congruent. So far things are looking good. This is what we would expect from a parallelogram. The opposite lengths are the exact same value. They're congruent. Okay, now we would have to look at the slopes. So let's do the same thing. I'll do the slope of AB, and then you should pause it and you find the other slope. So let's do the slope of AB. All right, so that's going to be y2 minus y1, 2 minus 3 over 1 minus 6. So slope of AB here, negative 1 over negative 5. And we want to reduce that to simplest form, so negative divided by negative. My slope is positive 1/5. Okay, so you pause it here and do the slope of BC, the slope of CD, and the slope of DA. Go ahead. All right, and once again, here are the answers popping up here, and you'll notice that we've shown here with the slopes that opposite sides have the same slope, so opposite sides are parallel. Notice that they're not opposite reciprocals. So we're not getting opposite reciprocals, which means we're not getting 90-degree angles at the angles. All right, now that we've done all that math, now we kind of come to our conclusion. So we can see now for sure that Jolene was correct. ABCD is a parallelogram, right? And then what we'd want to do is we'd want to reference all the math we just did. We want to cite our evidence. So first thing is we've proven opposite sides are congruent, and we have AB equals CD is square root of 26, BC equals DA is the square root of 61. Opposite sides are parallel, showing that these slopes were the same. And then finally, we'd want to mention that the angles do not form 90 degrees because the slopes of the intersecting sides were not negative reciprocals, right? Like 1/5 and 6/5 is not a negative reciprocal. So that's important to know that this is like not a rectangle, for example. Our evidence proves that ABCD must be a parallelogram. So that's kind of the thinking, the conclusion you have to go through, citing all your evidence to really know for sure this is a parallelogram. Okay, I'm going to kind of let you practice these ones on your own if you'd like to. You can do one more. They're asking us here what type of triangle is ABC, and be as specific as possible. So why don't you pause it here, find the lengths of every side. All right, with the answers popping up here, so you can see that what we've shown here is that side AB and side BC are the exact same length. They're both 4 times the square root of 2. And then this line here, AC or CA, is 8. So right now, at the very least, we know that this is an isosceles triangle. So we can say that to begin with. But we wouldn't want to stop there. We also want to see if there's something we can see about the slope. So like maybe we have a 90-degree angle. So I recommend you pause it again here, find the slope of each line. All right, and here the answer is popping up again here for you. So what you should have seen is that these two slopes are not the same, but they're opposite reciprocals of each other. And then this slope is undefined, which makes sense, it's a straight line. So what that's telling us with these opposite reciprocal slopes is that these lines meet at a 90-degree angle. So going back to the whole kind of big idea, what's our conclusion? Well, we showed that these two lines were equal, and then we just showed that this is a 90-degree angle. So we can say for sure that triangle ABC is an isosceles right triangle. We have the evidence for both of those things using distances and slopes. All right, if you'd like some extra practice here, check out these two sites on Khan Academy. These are some practice problems, this first one, and then if you just want like kind of another video explanation with some visuals, check out this video as well. These will both be linked to the YouTube video in the description. And you're ready for the exit ticket. Be prepared to show your work on this exit ticket and upload your scratch paper. You're basically going to prove one shape, just like we kind of did today in our example. So good luck to you.